Hi guys, welcome to the 31st video of Love Babbar 450 question series. So we are doing searching and sorting. We are halfway through and we have finished array, matrix and strings. So if you have not watched the earlier videos, I will put all the videos in a playlist and put the link of the playlist in the description. And questions, this sheet link, this Google Sheet link also will be there in description. And all the problems that I solved, the solutions also will be there in the description. Okay, so let us start with today's problem. Before that, I would just like to say that thank you for supporting me for such a long time. Please continue to do so. Like this video, share it with all your friends and subscribe. And yesterday I had actually asked you to solve this problem. In the last video I had asked you to solve which problem, this one, right? Find four elements that sum to a given value. I hope you have done it. It was not so hard. It was not so tough. If you want me to make a separate video on it, I had already given you hints. I had told you like first solve the three sum problem and then come to this four sum problem. So if you have done it, very good. If you haven't, then just let me know. I will make a separate video. But I seriously suggest you to try it by yourself once, at least. Okay. So today's problem, it's quite simple only. Given an array of n integers, find total count of subarrays having their sum 0. Now I want you to do one thing. Go to GFG and find out count of subarrays, with sum equal to k. This is the general problem. Okay, this is a general problem. First, go and learn this. After going and learning this, what you should do is simple. Make k as what? 0. So if you make k as 0, you will get the answer to this problem. So how to solve the problem? Let me first copy this. I will show you my coding and the logic with an example I'll show you. So I'll show that. Now, basically we will take a map, okay? We will take a map and let us keep calculating the prefix sum. So let us keep taking summation. We will traverse through the array. If sum becomes 0, then we will do count plus plus. If we find the sum in the map already, then we will say count plus equal to map of sum, whatever this value is. And we will keep doing map of sum plus plus. Now, what is this statement? Some of you might get confused over here. See, this might be easy to understand. Okay, but what is this statement? What does this mean? So let us take an example to understand this. What is this approach actually trying to tell us? So suppose the array is 0, 0, 5, 5, 0, 0. Okay, suppose this is the array. Then let us traverse through the array like this. We get first 0. So we got one subarray. Then we get second 0. We got one more subarray. But then there are two zeros. So this also is one subarray. So one more subarray. Now we will come here. Sum will become 5. We will go here. Sum will become 10. We will go here. Sum will become 10. See, sum has not changed now. Sum was 10 over here. Sum is 10 over here also. If the sum has not changed, then what should we understand? This element is 0. That is most important in this problem. This approach, what is most important? This one. If the sum has not changed, that means that element is 0. That is why we are using a map over here to find count of such values. I hope you have understood why we are using the map. What is this count plus is map of sum? What is this statement? I hope you have understood with this example. See, we had the sum 10 till here At this point, we had sum 10. Okay. We were traversing through the array. We got a sum 10, right? Over here also 10. See, these two values are matching. That means when the sum has not changed, definitely this element is a 0. Similarly, again over here, definitely element is 0. I think it became a little untidy. I will just remove this. I'll tell you once again. So it was what? 005500. So sum became 5 here. Sum, okay. Sum became 10 here. Sum became 10 here. Here also 10, here also 10, here also 10. The sum has not changed only. That means these elements are zeros. Because if they are not zeros, the sum would change, right? These two would not be equal. Because these two are equal, that means we know that this element is 0. So that is what this map is doing. I suggest you to go and try it by yourself, try run many examples and check. You will understand what this statement means. So that is how you solve this count subarrays problem. And go check in GFG how to solve count subarrays with sum equal to k. That is the standard regular problem. Okay. The variation of that is one of this only, count subarrays with sum 0. I hope you have understood this one. Let us go to next problem. Next problem is also quite easy. We are given an array of integers. We have to find a product array such that P of I is equal to product of all elements except A of I. So I think reading that statement once you would have understood what the question is asking, but still let me explain it to you once. Let us take a general example. Suppose the array is 1, 2, 3, 4, 5. This is our array A. What should be our product array P? Leaving this element product of all these elements. So 2 into 3 into 4 into 5. What is that? 120. Leaving 2 product of all elements. So 1 into 3 into 4 into 5. That is 60. Leaving 3 product of all other elements. What will that be? I think it is going to be 40. Leaving 4 all other elements. Product of all other elements. So 1 into 2 into 3 into 5. What is that going to be now? 30. And leaving 5 product of all other elements is 24. So this array we should return. So what we could have done is one approach was what? One approach was let us find product of all. Let us find what? Product of whole array. So product of whole array is 120. Then my product array P will be 120 by 1, 120 by 2, 120 by the element, 120 by 3, like that, 120 by 4. So find the full product and divide it. But this method we should not do in this question, because in this question they're saying you should not use division. Time complexity should be O of n, space also O of n, but we should not use this division operation. Try to solve the problem without division operation. How to do without division operation? And if we do division operation, division by 0 also will be there. So we'll have to take that also into account. It won't be a problem, but just saying that we should not do with division. How to not do it with division? So we have to take extra space over here. So we need to create a prefix array and we need to create a suffix array. Prefix array will store product from 0 to n, and suffix array will store product from n to, sorry, this should be 1. Okay, 0 to n minus 1. So it will store from 0 to n minus 1 and this n minus 1 to 0. So prefix array, suffix array we need, and we need to store the products. So how will my prefix and suffix array look like? So my prefix array will be, for this example, 1, 1 into 2, 2, 2 into 3, 6, 6 into 4. See, I'm doing this 1 into 2, 2 into 3, 6 into 4, 24 into 5, 120. Suffix array will be what? 5, 5 into 4, 20, 20 into 3, 60, 60 into 2, 120, 120 into 1, 120. I hope I'm doing correctly over here. Yeah, so I have been doing correctly only. So how will this help us now? So how is this going to help us? Let me remove this and I'll show you the other code. So I've copied the code. So we need to build the prefix array. This is the prefix array, how to build the prefix array. Okay. Now the suffix array, how product prefix and product suffix array where we have built over here. And now the answer product are the vector that we have to return, the answer. So if I is 0, we will return suffix of I plus 1. If I is n minus 1, we will return prefix of I minus 1. Otherwise, we will do prefix of I minus 1 into suffix of I plus 1. Why we are doing this? See, now what will happen? Like, suppose we are at this element, we will do prefix of I into prefix of I minus 1 into suffix of I plus 1. So we will get 60 here. Suppose we are over here, we will just do prefix of I, which is 24. Suppose we are here, we will do suffix of I plus 1, which is 120. That means what I want to say is, if there is some element over here, we will find product of all the elements here, that is suffix of I plus 1. And we will find product of all elements before this, which is prefix of I minus 1. And we have to multiply these two. So I hope you have understood this problem. You can have a look at the code again. Okay, so it's a pretty easy problem. Let us go to next one, sort the array by set bit count. Now I will do this problem in the next video. I will do using constant space, because now I have not done using constant space. I have done using the vector, the pair, and I've used a lot of STL. But in interviews, they will ask you not to use STL. They will ask you the actual concept, like there will be a specific method only to do it. So STL code, if you want for this, you can just use multi-map or whatever, and it is a brute force kind of problem only. See, what is set bit? I hope you all know what is set bit. So set bit means, for example, if the binary number is 00101, set bit is this 1. Set bit means 1. So how many ever ones are there? Count of ones. According to that, you have to sort the array. So I will do this problem in next video. If you want the solution of this problem by using STL, I will give it in the description, okay? So thank you all for patiently watching till here. If you really did like the video, I will know how many people watched till here. And please share the video with all your friends, subscribe, and stay tuned for the next one. Have a good day. Bye. See you.